Hey everyone, and welcome to RUBIN'S MindLab, where we break down the latest research into what it really means. Ever wondered how psychologists figure out what is happening in your brain while you are doing something? Like moving your mouse to click a button. Well, today we're diving into a fascinating study that explores just that. This research is all about understanding the subtle dance between our thoughts and our actions. Specifically, how we track those actions over time. Imagine you're about to pick one of two doors. Your mind is buzzing with possibilities. Maybe you feel a pull towards one, then a hesitation, then a quick decision. Mouse tracking is a cool way scientists try to capture that internal struggle by watching how your mouse moves. It's not just about where you end up, but the entire path you take to get there. The big question in this paper is, when we analyze these mouse movements, which parts of the movement tell us what we really want to know about our thoughts, and which parts might be misleading us? It turns out, how you prepare and process that movement data can totally change what conclusions you can draw. Think about it this way. You're drawing a line on a piece of paper. You can measure how far you strayed from a perfectly straight line. But what if you decide that your start and end points are actually the real points you wanted to hit, no matter what? Or what if you compare your line to a pre-drawn path on the paper? This study looks at different ways researchers process these mouse movements, what they call spatial preprocessing. They focus on two main ways of looking at the movement: comparing it to a straight line between the actual start and end points of the mouse path, or comparing it to a fixed path set by the experiment itself. They also looked at three ways to line things up or align the data. One way is called start alignment, where they shift every mouse path so it starts at the same spot. Another is start plus end alignment, where they not only make the start points the same, but also make the end points match. Here is the critical part. If you use that first method, comparing the path to the line between its own start and end points, you are basically telling the data that at the very beginning and the very end of the movement, there was no deviation. It is mathematically impossible for there to be any difference there with this method. This might sound technical, but it has huge implications for what psychological questions we can answer. If you're looking for evidence of a thought process happening right at the start of the movement, or right at the moment you finish, and you've used this Own-Endpoint method, you're out of luck. You've already forced those points to be zero. To test this, they ran simulations. They created fake mouse movements with known effects happening at different points, at the start, in the middle, or at the end. Then they ran these fake movements through all the different processing methods called pipelines to see which method recovered the original known effect best. What they found was eye-opening. If the real effect was happening at the beginning or end of the movement, the methods that constrained those endpoints would mess things up. They'd either hide the effect or make it look like it was happening at the opposite end of the movement. For example, an effect that started early might be made to look like it happened late. However, if they used a method that didn't force the endpoints to be zero, specifically the design path without alignment, they could recover the true effects at the start and end quite well. This suggests that if you want to understand what's happening at the very beginning or very end of an action, you need to use a method that doesn't automatically remove that information. They also tested their findings by changing other factors like how much they smoothed the data, how much noise they added, or how variable the endpoints were. No matter what they did, the core conclusion held: if you constrain the endpoints, you can't study what happens at those endpoints. To show this in real life, they used data from a Simon task. In this task, people are asked to press a button based on the color, but the location of the stimulus might either match or mismatch the required button. When it mismatches, it's called incongruent, and it makes things harder. They found that incongruency delayed the start of the movement, but it delayed the actual movement itself much more. This meant that the mental struggle, the conflict, was happening while the person was already moving. But here is the kicker. Even with this real data, depending on which processing method they used, they could tell different stories. One method might make it look like the problem was all at the beginning, while another might suggest it was a problem at the end. This highlights how crucial the pre-processing choice is. Essentially, the way you prepare your data sets the stage for what scientific questions you can even ask and what answers you can get. If you cut off the beginning or the end of the story, you can't talk about what happened then. The researchers want to help scientists make better choices. They provide a guide to help researchers pick the right method based on what they want to study. They emphasize that it is important to define your research question, your estimate as they call it, which is the exact thing you want to measure before you choose how to process your mouse movement data. So what's the main takeaway here for us? The curious minds trying to understand ourselves. It's that the path matters, but how we measure that path matters even more. When we look at studies that use mouse tracking, it is really important to understand how the data was processed. If a study looks at how our actions unfold over time and it uses methods that force the start and end points to be identical or zero, we need to be cautious about any claims it makes about what's happening right at the very beginning of our decision or right at the very moment we complete an action. This doesn't mean mouse tracking is bad. Far from it. It's an incredible tool for understanding the moment unfolding of cognitive processes. But like any tool, you need to use it correctly and understand its limitations. The researchers are essentially saying that pre-processing choices aren't just technical steps. They are part of the psychological model itself. They shape what evidence we can gather about our internal mental lives. So for future research and for how we interpret existing research, the key is transparency. Researchers should be clear about how they prepare their mouse tracking data and what specific questions their chosen pre-processing method allows them to answer. And perhaps more importantly, what it prevents them from answering. This research is a great example of how careful methodological choices can profoundly impact our understanding of complex cognitive processes. It's a reminder that behind every scientific finding, there is a story about how the data was collected and analyzed. And that story is just as important as the result itself. It also makes me think about everyday actions. When we procrastinate or when we struggle to make a decision, that whole process from the first flicker of thought to the final action is complex. Mouse tracking helps us see that complexity, but we need to be smart about how we analyze it. My take on this is that the unaligned design path method seems to be the most robust if you want to understand what is happening at both the beginning and the end of an action. It's like getting the full movie, not just a snippet. The constrained methods are useful if you are only interested in the middle part of the action, the curvature, as they call it. But they can't tell you about the opening or the closing scene. The limitations mentioned, like the fact that real cognitive and motor dynamics can be messy and not always smooth, are also important. This study used a simplified model, and real life is often more complicated. Future research could explore these more complex scenarios. Ultimately, this study is a call for more clarity and intention in how we use sophisticated tools like mouse tracking. It's about ensuring that our methods serve our scientific questions rather than limiting them. What I find most compelling is how this research directly impacts how we interpret experiments designed to understand cognitive processes like decision-making or response conflict. It's not just an academic exercise, it directly affects what we can say about human psychology. So, the next time you see a study using mouse tracking, ask yourself, what story is this method telling about the beginning, middle, and end of the action? The biggest strength here is that the researchers didn't just theorize, they simulated and showed real data. They provided clear guidelines for other researchers. The limitation, as they note, is that real-world cognition is more complex than their simulations, but that's true for most foundational studies. This work really sharpens the focus on what we can and cannot conclude from mouse tracking data. It forces us to be precise about our estimates, the specific quantity we are trying to measure, and to choose our pre-processing methods accordingly. It would be really interesting to see future studies apply these principles to understand things like why some people are better at resisting distractions than others, or how learning new skills affects the timing of our movements. This is a fantastic piece of research that makes a critical point about scientific methodology. It's a great reminder that the devil is often in the details, especially in how we prepare our data for analysis. So, if you enjoyed this deep dive into how we study the mind, please give this video a thumbs up. Let me know in the comments what you think about these findings, and if you have any questions, and of course, don't forget to subscribe to RUBIN'S MindLab for more explorations into the fascinating world of psychology. Thanks for watching, and I'll see you in the next one.